Good morning, students. This is Murthy sir. In the last class, we discussed about important terms in metallurgy, the different types of ores of metals, and the introduction to metallurgical processes. Today, we will discuss about the concentration of ore and extraction of metals in detail. Students, the process of removal of unwanted material from the ore is known as concentration or dressing or benefaction of ores. It involves several steps. The separation of required material from the ore is dependent on the differences in physical properties of the compound of the metal present and that of the gangue. Already you know. Students, already you learned about gangue. Gangue is earthly impurities present in ore along with soil and clay. Students, the first method in concentration of ore is hand picking. It was the traditional method of concentrating ore directly with hands. In this method, the gangue or adhering solid matrix is separated from the ore with the help of a hammer. The separation and identification of gangue are done based on the differences in color or lump shape. Students, this hand picking is the first method in concentration of ore. Now let us move on to the second method, hydraulic washing. The second method, hydraulic washing, is based on the difference in gravity of the particles of the gangue and the ore. So it is considered as a type of gravity separation. During this process, an upward stream of running water is used to wash the powdered ore. The lighter gangue particles are washed, leaving the heavier ore particles. So this hydraulic washing is the second method of concentration of ore. The third method is froth flotation. It is a process for selectively separating hydrophobic materials from hydrophilic materials. This is used in mineral processing, paper recycling, and wastewater treatment industries. The froth flotation method is mainly used for sulfide ores. The ore with impurities is finely powdered and kept in water taken in a flotation cell. Air under pressure is blown to produce froth in water. Froth so produced takes the ore particles to the surface, whereas impurities settle at the bottom. Froth is separated and washed to get the ore particles. In this froth flotation cell, let us see the labeling. Ore, oil and water, compressed air, froth with ore, gangue. Generally in this froth flotation cell, pine oil is used. The fourth method of concentration of ore is magnetic separation. It is a process of separating components of mixtures by using magnets to attract magnetic materials. Due to the magnets, magnetic particles are being drifted by the movement of the drums. This can create a magnetic concentrate. Example, an ore concentrate. If the ore or impurity, one of them is magnetic substance and the other is non-magnetic substance, they are separated by using electromagnets. Let us see the apparatus. The labeling is given here. Finely ground ore, magnetic roller, magnetic particles, non-magnetic particles. So this is the fourth method of concentration of ore, magnetic separation. Now let us move on to the second metallurgical process, extraction of metals. The isolation of metal from the concentrated ore involves the refining of metals from the compounds it is found with to its original state. The concentrated ore is first converted to an oxide, after which metal extraction is done by reducing it from an oxide to metal using a suitable reducing agent. Students, already you learnt about activity series of metals. Now here let us see the extraction of metals in the top of the activity series, highly reactive metals. The metals at the top of the activity series are highly reactive. They cannot be obtained from their compounds by heating with carbon. These metals have more affinity for oxygen. These metals are obtained by electrolytic reduction. Students, sodium is extracted from sodium chloride through electrolytic reduction. Here you can see the process. Molten sodium chloride undergoes electrolysis to produce solid sodium metal and chlorine gas. Students, in this electrolytic cell, sodium is deposited at cathode and chlorine gas is collected at anode. You can see the apparatus here. One battery is there and two electrodes are there. So this is the electrolytic reduction to get the sodium metal. Now let us see the extraction of metals in the middle of the activity series, that is moderately reactive metals. Extracting metals in the middle of the activity series, that is metals such as iron, zinc, lead, copper, etc. They are in the middle of the activity series or reactivity series. These are moderately reactive metals and are usually present as sulfides or carbonates. A metal is obtained from its ore by the processes of reduction or by electrolysis. Now let us see one example. Lead metal is mainly extracted from its sulfide ore called galena. Roasting is done, followed by reduction with carbon. Self-reduction finally takes place. Here you can see the chemical equation or chemical reaction. Lead sulfide reacts with lead oxide to form lead metal and sulfur dioxide is formed. Now let us see the extraction of metals in the bottom of the activity series. Metals at the bottom of the activity series are often found in free state. They are least reactive. The oxides of these metals can be reduced to metals by heat alone and sometimes by displacement from their aqueous solutions. When cinnabar, the ore of mercury, is heated in air, it is converted into mercuric oxide, then reduced to mercury on further heating. You can see the chemical reactions here. Let us see the chemical reaction. Mercuric sulfide reacts with oxygen to form mercuric oxide and sulfate. Mercuric oxide on further heating forms mercury metal and oxygen is formed.